Hello. In this video we will firstly see how ClassWiz can be used to represent indices, and we will then consider some ways in which they can be used to help students to learn about their properties. So turn on your ClassWiz and let's set it up. We'll be using calculate mode in this video. You can see here that's with number 1, menu and number 1. And we'll need to use math mode. So tap shift and setup and select input and output and choose number 1 for math mode, mathematic input and output. There are 3 ways to represent indices on the ClassWiz. Let's look at an example. To represent 7 to the power 3, we could multiply 7 by itself 3 times. 7 multiplied by 7 multiplied by 7. We can use the powering key by first entering the base of 7, and then here's the power key here, tapping the power key and then entering the power or the index of 3. Notice the flashing cursor stays in the index, and we get of course the same result, which is 343. A third way, which is available only for squares and cubes, is to use a special keyboard command. In this case 7, and you notice above the x squared key, there's in yellow, there's a cube. Tap shift and the x squared key, and you can see the small cube symbol is shown. And this time the cursor is not in the index. That's important to notice, and we'll say more about that later. Of course, the result is the same with all 3 methods. We will mostly use the power key in this video. As for fractions, you need to be careful with entering expressions with indices. So for example, if we wanted to enter 7 cubed add 5, if you start by adding 7 to the power 3, if we simply now add 5, notice the cursor is flashing in the index and we get 7 to the power 3 add 5, which is not the intended result. So what you need to do is firstly start with 7 to the power 3. Notice where the cursor is, it's flashing up here in the index. Move to the right and then add the addition sign and then the 5, and 7 cubed add 5 is 348, as you can see. So the correct expression is shown. This expression up here matches the expression that we were trying to produce, which gives us, of course, the correct result. But now we've seen how to enter indices into ClassWiz and seen how ClassWiz represents them, let's consider what can be learned about indices by students using the calculator. Firstly, ClassWiz allows students to find the prime factors of a counting number, which of course are expressed using indices. For example, after a number is entered, tap the factor command. So let's enter a number like 625. The factor command, you notice here, is above the degrees, minutes and seconds command, and it's in yellow. So we tap shift and then the factor command, and the ClassWiz shows the factors of 625, the prime factors. In this case you can see it shows them as indices, 5 to the power 4. In other cases, several different prime factors may be involved. So here's an example of 180, and if we find the prime factors, shift and the prime factors, we see that 2 squared by 3 squared by 5 is 180. This will give students some intriguing problems to study, understanding how fractions works. But importantly, this allows students to see for themselves what happens when powers of the same base are multiplied. So for example, many students would expect that 11 to the power 5 multiplied by 11 to the power 3 would be 11 to the power 15, because they think things are being multiplied together. And when they get the result on ClassWiz, it's a very large number, but we can use the factor key to see that in fact 11 to the power 5 by 11 to the power 3 is 11 to the power 8. So the ClassWiz can stimulate them to think about what's happening here and why is it happening. This idea is used in an investigation in the Investigating Mathematics with ClassWhiz book, which you can download from the Casio Worldwide Education website. Because ClassWhiz finds prime factors, when the base is not a prime factor, students will need to think carefully about the results. For example, 6 to the power 4, and use the arrow key to move out of the power, multiplied by 6 to the power 5, I forgot to press the power key, 6 to the power 5. And when they find the factors, students might expect it to be 6 to the power 9, but it's not 6 to the power 9 because it's prime factors that are involved. So this allows students to see why is it 2 to the power 9 times 3 to the power 9 and not 6 to the power 9. This gives students some stimulation and some opportunity to find out how these powers work together. And the ClassWhiz allows them to find other examples of how indices work. For example, 6 to the power 14 is a very large number, but it's too large for students to explore with the ClassWhiz. So students will need to be careful about the sizes of the numbers, but when they're just learning about indices, that of course is not a problem. So let's look at a different kind of example where students can see for themselves some of the properties of indices. So we'll think of 2 to the power 3, and I'll close the bracket. We're going to raise 2 to the power 3 all to the power 5. And here's the result. Is again a large number, and if students find the factors of that number, they can see 2 to the power 15 and can see that in this case the indices 3 and 5 have in fact been multiplied. And students can think about the meaning of this and enter results for themselves to find out how these things work. They could of course enter results the long way, 2 to the power 3 multiplied by 2 to the power 3, 5 times over. This is a little bit tedious, but it's important when students are learning that they are comfortable with representing numbers on their ClassWhiz, thinking about what they mean. So here we have 2 to the power 3 multiplied by itself 5 times. Wrong one. 5 times. And the result is again a very large number, but the ClassWhiz can be used to see that indeed it's 2 to the power 15. The same idea works for division, where when powers are divided by each other, for example 7 to the power 9 divided by 7 to the power 5 is a large number, but again if we find the factors of that number we can see that it's 7 to the power 4, and of course 9 subtract 5 is equal to 4. So it's valuable for students to represent this kind of operation also using fractions. And the ClassWhiz allows them to do this. So for example, let's make the fraction 11 to the power 6 divided by 11 to the power 2. We represent the number that way, and the result, if we find the factors of the result, we can see is 11 to the power 4. Now, of course, we don't expect students to always use their ClassWhiz to get these results. The point is they can use their ClassWhiz to understand what's happening and to see the general result and think about why it is like that. It's important in mathematics to have reasons. So once the students are confident with dividing numbers expressed as powers, they will be less surprised than they would otherwise be to see what might look like strange things to them, like 15 to the power 0. It's hard to understand what a power of 0 might mean, but another number like 135 to the power 0, how do you multiply something by itself 0 times? But of course, if they understand the laws of indices, they would understand that 15 to the power 5 divided by 15 to the power 5 is going to give the result of 15 to the power 0, which of course is 1, and it's clear to them that 15 to the power 5 divided by itself is 1. When students are comfortable with the addition law of indices, they can use it to think about negative indices, which are otherwise very hard to understand. So for instance, 2 to the power negative 3. What can it mean to multiply something by itself negative 3 times? Of course, the class whiz produces the result 1/8, which students will recognise as 1 divided by 2 to the power 3. So they can get some insight into the meaning of negative indices. And of course, the best insight comes from thinking about a number like 8 to the power 3 multiplied by 8 to the power negative 3, and knowing what they do about adding the indices. Negative 3 and 3 make 0, and so the result is of course 1, 8 to the power 0. Negative indices can be interpreted directly on class whiz using small integers for which students recognise the powers. So for example, 3 to the power negative 3, students should understand 3 to the power 3 is 27, and so that's 1 over 27. And likewise, 2 to the power negative 5 is 1 over 32, because 2 to the power 5 is 32. In a similar way, students can enter fractions with powers in the denominators to see that they give the same value as the associated negative powers. Here's an example. Think of 1 divided by 2 to the power 5 is 1 over 32, and 2 to the power negative 5 is also 1 over 32. So students can see that these give the same result, and indeed on their class whiz they can multiply 2 to the power negative 5 by 2 to the power 5. Think about the laws of indices. Negative 5 and 5 make 0, 2 to the power 0 should be 1. So the class whiz helps them to make sense of all of these things. Indices that are not whole numbers are hard for students to understand at first. But once they get a good grasp of the addition law, they can be helped to see a way to make sense of them. Consider 6 to the power 1/2, for example. Clearly this should be larger than 1, which is 6 to the power 0, but less than 6, which is 6 to the power 1. But if this number is multiplied by itself, and I use the arrow key twice to have the cursor outside the fraction here, outside the number, we multiply the number by 6 to the power 1/2, again. The laws of indices will help them to see that a half and a half add to 1, and so 6 to the power 1/2 by 6 to the power 1/2 should be 6 to the power 1, which is 6, which is very surprising that these strange numbers can work in those kinds of ways. Students can check these kinds of things directly, of course, on their class whiz. So they can enter 6 to the power 1/2, like so. See the value as a decimal, and then use the class whiz to find the square of the answer, the x squared key, and see that the answer gives 6. So that 6 to the power 1/2 is the same thing as the square root of 6. And indeed on the calculator, the square root of 6 is shown here. It's the same as we had before, and if we square that result, we get 6. Students can be challenged to think about fractional powers such as 8 to the power 1/3. What could be the meaning of 8 to the power 1/3? So 8 to the power 1/3, what could that be? And perhaps it might mean that if we multiply that by itself, 1/3, and again by 1/3, we should get, if the laws of indices are operating, a third and a third and a third add to 1, and so the result will be 8 to the power 1. And they can explore this topic even further using their class whiz as a powerful tool. For example, if you consider 32 to the power 3/5, students can use the class whiz to think about this in various ways. They might think about it as the result is surprisingly 8. They might think about it as the cube of 2, and that is 32 to the power 1/5, which is like so. That result is 2, and if we raise that to the power 3, the result is 8. So 32 to the 3/5 is the same as 32 to the 1/5 cubed. So students can use their class whiz to explore those kinds of relationships and to understand how indices work and what they mean and what their properties are. The video has shown you some of the ways in which students can do this. We've looked briefly at laws for multiplying and dividing powers to the same base, multiplying powers together, and importantly the meanings of negative and fractional and zero indices. In all of these cases, class whiz provides good representations of the computations and a way to understand them and how they can be summarised with neat laws. You'll find Module 2 of the class whiz book, which is this one here, Learning Mathematics with Class Whiz, contains lots of detailed information on how class whiz works with indices and powers, and many useful ideas to think about how it can be used for educational purposes, as well as detailed explanatory text which can be copied for students as well as teachers. The module includes some exercises to check efficient class whiz use and some examples of activities to suggest educationally valuable things to do, as well as some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. We hope that you find the video and the printed resources useful. Happy calculating!